Deep learning. Question 1. What do you mean by deep learning? Deep learning is nothing but a paradigm of machine learning which has shown incredible promise in recent years. This is because of the fact that deep learning shows a great analogy with the functioning of the neurons in the human brain. In this diagram, we can clearly see that deep learning is a subset of machine learning and machine learning is a subset of artificial intelligence. So, according to this, a technique which enables machine to mimic human behavior, that is called artificial intelligence. Machine learning, a subset of AI technique which use statistical method to enable machines to improve with experience. And deep learning, subset of machine learning which make the computation of multi-layer neural network feasible. Question number 2. What is the difference between machine learning and deep learning? Machine learning is a field of computer science that gives computers the ability to learn without being explicitly programmed. Machine learning can be categorized in the following 4 categories. Number 1. Supervised machine learning. Number 2. Semi-supervised machine learning. Number 3. Unsupervised machine learning. Number 4. Reinforced learning. So, deep learning is a field of machine learning concerned with algorithms inspired by structure and function of brain called artificial neural network. In this diagram, we can see the process in machine learning where there is input, there is feature extraction, and then classification, and then output. While in deep learning, we see the input and then feature extraction plus classification happens at the same time, and then we get the output. The main difference between deep learning and machine learning is due to the way data is presented in the system. Machine learning algorithms almost always require structured data, while deep learning networks rely on layers of ANN, that is, artificial neural networks. Machine learning algorithms are designed to learn to act by understanding labeled data and then use it to produce new result with more dataset. However, when the result is incorrect, there is a need to teach them because machine learning algorithms require bulleted data. They are not suitable for solving complex queries that involve a huge amount of data. Deep learning networks do not require human interventions as multi-level layers in neural networks place data in a hierarchy of different concepts, which ultimately learn from their own mistakes. However, even they can be wrong if the data quality is not good enough. Data decides everything. It is the quality of data that ultimately determines the quality of the result. Both of these subsets of artificial intelligence, that is the machine learning and deep learning, are somehow connected to data, which makes it possible to represent a certain form of intelligence. However, you should be aware that deep learning requires much more data than a traditional machine learning algorithm. The reason for this is that deep learning networks can identify different elements in neural network layers only when more than a million data points interact. Machine learning algorithms, on the other hand, are capable of learning by pre-programmed criteria. So this was a difference between machine learning and deep learning. Question number 3. What in your opinion is the reason for the popularity of deep learning in recent times? Now, although deep learning has been around for many years, the major breakthrough from these techniques came just in recent years. This is because of the two main reasons: the increase in the amount of data generated through various sources, the growth in hardware and resources required to run these models. GPUs are multiple times faster and they help us build bigger and deeper deep learning models in comparatively less time than we required previously. Question number 4. What is reinforced learning? Reinforced learning allows to take actions to max cumulative reward. It learns by trial and error through reward penalty system. Environment rewards agent, so by time agent makes better decisions. For example, robot is equal to agent Maze is equal to environment used for complex tasks like self-driving cars, game, artificial intelligence. Reinforced learning is a series of time steps in Markov decision process. Number 1. Environment space in which reinforced learning operates. State data related to past action. RL took. Action taken. Reward number taken by agent after last action. Number 5. Observation data related to environment can be visible or partially shadowed. Question number 5. What are artificial neural networks? Artificial neural networks are a specific set of algorithms that have revolutionized machine learning. They are inspired by biological neural networks. Neural networks can adapt to changing the input, so the network generates the best possible results without needing to redesign the output criteria. Question number 6. Describe the structure of artificial neural network. Artificial neural networks works on the same principle as a biological neural network. It consists of input which get processed with weighted sums and bias with the help of activation functions. In this diagram we can see the structure of artificial neural network. X1 up to Xn are inputs and W1 up to Wn are weights, and then sum, and then B is called bias, and then activation function, and then Y is equal to output. So this is diagram of structure of artificial neural network. Question number 7. How are weights initialized in a network? There are two methods here. We can either initialize the weights to 0 or assign them randomly. Initializing all weights to 0. This makes your model similar to a linear model. All the neurons and every layer performs the same operation, giving the same output and making the deep net useless. Initializing all weights randomly. Here, the weights are assigned randomly by initializing them very close to 0. It gives better accuracy to model since every neuron performs different computation. This is the most commonly used method. Question number 8. What is the cost function? Also referred to as loss or error. Cost function is a measure to evaluate how good your model's performance is. It's used to compute the error of the output layer during backpropagation. We push that error backwards through the neural network and use that during different training functions. The most known one is the mean sum of squared errors, that is MSE, is equal to 1 by n summation of I from 1 to n yi minus yi whole square. Yi is predicted value and then another is actual value. So that's how we calculate MSE, mean squared error. Question number 9. What are hyperparameters? With neural networks, you are usually working with hyperparameters once the data is formatted correctly. A hyperparameter is a parameter whose value is set before the learning process begins. It determines how a network is trained and the structure of network, such as the number of hidden units, the learning rate, epochs, batches, etc. Question number 10. What will happen if the learning rate is set inaccurately, too low or too high? When your learning rate is too low, training of model will progress very slowly. As we are making minimal updates to the weights, it will take many updates before reaching the minimum point. It is the learning rate is set too high. This causes undesirable divergent behavior to the loss function. Due to drastic updates in weights, it may fail to converge. Model can give a good output or even diverge. Data is too chaotic for the network to train. So this will happen if we set learning rate inaccurately, too low or too high. Question number 11. What is the difference between EPOCH, batch and iteration in deep learning? EPOCH represents one iteration over the entire dataset, everything put into the training model. Batch. Batch refers to when we cannot pass the entire dataset into the neural network at once. So we divide the dataset into several batches. Iteration. Iteration, if we have 10,000 images as data and a batch size of 200, then an EPOCH should run 50 iterations. 10,000 divided by 50. So this is the definition of EPOCH, batch and iteration. Question number 12. What are the different layers on CNN? In the following diagram, we can see different layers of CNN, convolution network, neural network. So there is input and then convolution plus ReLU, that is rectified linear unit, that is ReLU. Then pooling, then convolution plus ReLU, rectified linear unit again, then pooling, then classification part, flatten, fully connected and softmax function. So these are the different layers of convolution neural network. So the convolution neural network are regularized version of multi-layer perceptron, that is MLP. They were developed based on the working of neurons of animal visual cortex. In this diagram, we can see the images of puppies and then what computers see in the form of digits. What we see is puppies and then it is converted into machine language, what computers see in the form of digits. Let's say we have a color image in JPG form and its size is 480 into 480. The representative array will be 480 into 480 into 3. Each of these numbers is given a value from 0 to 255, which describes the pixel intensity at that point. RGB intensity values of image are visualized by computer for processing. The objective of using the CNN. The idea is that you give the computer this array of numbers and it will output numbers that describe the probability of image being a certain class. That, for example, 0.80 for a cat, 0.15 for a dog, 0.05 for a bird, etc. It works similar to how our brain works. When we look at a picture of a dog, we can classify it as such if the picture has identifiable features such as paws or forelegs. In a similar way, the computer is able to perform image classification by looking for low-level features such as edges and curves and then building up to more abstract concepts through a series of convolutional layers. The computer uses low-level features obtained at the initial levels to generate high-level features such as paws or eyes to identify the object. There are 4 layers in the CNN.